Alright guys, welcome back. This is lesson 1.4. So we're going to be going over the distributive property, and then we'll be changing topics slightly in the middle of the video and talking about relations. So for the most part, this video is going to be things you already know and a lot of vocab. Please make sure you know the vocab. Okay, if I can highlight anything this video before we get started, it's make sure you know the vocab. Because as the semester goes on, I will expect you to know this vocab. So please make sure you know the vocab. That being said, let's get started. The distributive property, probably studied it before. You know what it is. It is when you have a set of parentheses and then you multiply the number from the outside into the set of parentheses. Okay. What these two examples show you right here is it explains why this works or how this works. Okay. So you can look at this and read it. You can pause it if you want to know the general math of it. But me personally, I believe that you can understand this better by doing it. A few bits of vocab before we get started though. Like terms. Like terms are when you combined all of the same types of variables. So in this problem, you have two like terms. You have the a squares, and that's it. A by itself does not have a like term, is not a like term with a squared because there's always an invisible 1 right there. And this distinction is very important. You cannot combine an a squared with an a. Okay, it's kind of like combining apples and oranges. It doesn't work. All right. Another way to think about it is royalty. In places where there is a royal family, you don't often see the king associated with the commoner. So the more power you have, the more you hang out with people that have the same amount of power. So my a squares here have more power than my normal a, which means the a squares are going to stick together and combine. The normal a kind of gets left in the dark over here. Aw, poor a. Okay, so that's like terms. Simplest form is when all like terms have been combined and there are no more grouping symbols. So no parentheses, no brackets. All like terms have been combined. Okay. Now this example right here actually gets into some content that we'll do later on in the chapter. But you have 17x here and 25x here. What they did in this step is they pulled the x out of each number and put it up front. So think about it. If the distribution property, if you had x 17 plus 25 like this, well, you could distribute the x normally and you would get 17x plus 25x. This is the kind of distribution, that we're most used to. But don't forget, in math, if you can go forward, you can go backwards. So if you can plug something in with distribution, later on, there will be a property that allows you to pull the x's out, and put it back outside again. So we will get to this bit later. But just to let you know that that's coming and that's coming up. But back to simplest form. It is an expression that contains no like terms or any parentheses. If there was an x squared here, that'd be fine, but you could not have another x in this sentence because then it wouldn't be combined down to its simplest of forms. All right. Coefficient. The coefficient is the number that is in front of the variable. And that's basically it. And every time you have a variable, there will always be a number up front. Even if you have multiple variables, there will still be a number up front. Even if you have a variable by itself, there is always the invisible 1 that's up there. And that's all coefficient means. It's just the number up front. Okay? We will be using this word coefficient a lot. So if I'm going to put a star by this one, make sure you know this one, because this one will pop up in a lot of just usual casual math language. All right, with all the vocab out of the way, again, make sure you know that. Let's get down to work. So distributive property, you've probably encountered it in middle school. We're going to go over it again just to make sure we're on the same page. Whenever you have a grouping symbol, if ever there is something out front, you are going to distribute it to each of the terms inside the parentheses. Okay, now distributing is another way to multiply. So this is 7 times 3w, which gives us 21w. Okay, this is 7 times a negative 5, which gives us a negative 35. Once you distribute, check to make sure that if you have any like terms. If you don't, then put a box on it and walk away. That's the answer. Okay. Now on B, the common mistake for problems like B is to only distribute to the first term and forget about the other ones. So I will always, at least when I'm working problems on the board, do these little rainbow symbols with the arrows. And I advise you to do it too, at least for a little bit, and especially when you've got a long parentheses and a lot of things in it, because it forces you to distribute to every single term within the parentheses. Otherwise, it's very easy to forget that last term. Again, multiplication. 4 times 6 is 24, v squared. Notice your variables stay the same. Okay, this doesn't become a v8 or anything like that. Variables stay the same. You are only multiplying the coefficients. 4 times 1 is 4v minus 12. Okay, there are no like terms, so that is it. The other case I want to warn you about is if ever you have a negative up front. So let's say that you have, I'm just going to make up numbers here, 4 minus x plus 3. This negative sign up front, the only way to get out of this parentheses is to distribute the negative to each. Okay? Don't forget, this is a negative 1 up front, and you can distribute that negative 1 inside the parentheses to give you a 4 minus x minus 3. Distributing the negative sign is one of the biggest things that people forget to do. So always make sure that if you have a negative sign up front, that you distribute it into the parentheses. Okay? You guys go ahead and do this one. Make sure that when you're giving me your answer that you indicate the properties used. What that means is I want things like the additive identity or multiplicative inverse or substitution, or now the distribution property. Okay, these are all properties we know how to use now. The video is going to pause, do it in your notes, and go. Here is your answer. The answer is 11x plus 8y. You can't get any smaller than that. There are no more like terms, so that is your answer. Okay. Moving on. And this last slide, all of these properties we've talked about before, all of these properties we know, it's just putting them all together for you. Please make sure that you look over this and see if there's anything you don't remember or don't understand. Okay, because we will be using these properties a lot. As promised, we're going to switch gears now and move on to relations. If you are following along in the book, this is lesson 1.6, but I will continue to refer to this PowerPoint as lesson 1.4, meaning the 4th online day. If you are not following along in the book, then don't worry about it. So, relations, we are changing gears. Now, in algebra, there are 2 things you got to know before you leave this class in Algebra 1. The first thing is how to solve equations. Okay? If you don't know how to put numbers together by the end of this class, then we did something wrong. But the second most important thing you got to know how to do is to graph equations. Okay? These are the 2 big points of algebra, solving equations and graphing equations. This lesson with relations is the first part of graphing equations. Okay? So we are using the same equations that we've been using, but now we're going to talk about them in a slightly different way. Again, this is where it becomes vocab heavy. You need to make sure you know all of this vocab. Here we go. And I present you with the list of vocab. Scan over this. A lot of these words are going to be words you've seen before in middle school. Maybe you've seen all of them, maybe you've only seen a few of them. We're going to go over them one more time because these words will be used commonly. Okay, and after this PowerPoint, I will expect you to know what I mean if I say the origin or the x-axis or mapping or domain. Okay, here we go. If you don't know any of those vocab words, there is a list off to the side on your guided notes. Just keep up with the definitions. So a coordinate plane is a plane with an x and a y axis. It has 4 quadrants. In quadrant number 1, any point in over here is going to be positive. The x's and y's are both going to be positive. And to remind you which one's which, this is our x, this is our y. We do math the same way we read. The number that comes first in the alphabet will always go first in your coordinate plane. But on a coordinate plane, in quadrant 1, both x and y are positive. In quadrant 2, the x's are negative and the y's are positive. And the same thing around the board. In quadrant 3, both are negative. And in quadrant 4, the x is positive and the y is negative. Okay. Please make note as to how we write points. It is the x first, comma, the y. Both are in a parentheses. Okay? You have to have this parentheses. Have to. Because otherwise it's just 2 numbers chilling. You have to have the parentheses. That is what tells me it's a point. So whenever I ask you to give me your answer as a point, you need to have it in the parentheses. Otherwise, it's just 2 numbers chilling. Now, with relations, there is this language of functions. Okay? F of x. So it can be a very common thing you'll see. A function is another word for a relation that has an input and an output. Yes, so think about it. The word relation. Okay? Relations, how things relate to each other, how things connect. What is their common ground? Okay? What is the connection? When we're talking about functions, we have a clear connection. The domain is what goes into the function, the range is what comes out, your solution. So you even could say input and output. All right? Or oftentimes, if you're going to be doing an equation, let's say you have 2x plus 4 and x is equal to 3. X is equal to 3 is your input, your output, your answer would be 2 times 3 plus 4, which is 10. Your output would be 10. So whatever you put into the equation, whatever number, whatever anything that you put into the equation, that is your domain and that is your input. Your answer, or whatever number you get out of it, is called your range. Now, you may have heard of domain and range in a different context, and you would be correct. Let's go down here. Now, if I were to draw a graph like this, and I were to just draw a line, any line, there it is. Isn't it lovely? My domain would be the x's. So this is my x-axis, this is my y-axis. All of these numbers over here are my domain. So 1, 2, -1, -2, doesn't matter. My x's are always my domain. My y's are my range. So if it goes up and down, that's my range. Side to side is my domain. Another way you can see this illustrated is actually in a table. So let's say I have the parent function y is equal to x. Okay, y is equal to x gives me the standard line. If I can erase this one. Nope, it's not erasing. Anyway, it gives me the standard line that goes through the origin. I'm just going to draw another one. The iPad is not, helping me today. Standard line through the origin, there it is. Remember, my domain is my input. My range is my output. So whatever number I put into my domain will affect my range. So let's say in my standard equation right here, my parent function, let's say my x is 1, well then my y will be 1. If I put x2 into the equation, that will change and I will get y is 2. Another example would be, let's say this equation is all right. Let's say this equation is y is equal to 2x. Okay, so I put in my x's, and here are my y's. If I put a 1 into my x, my output is going to be a 2. Whatever the x is determines the y. That's the domain and range. But this is also why the x values are known as the independent variable. Okay? The x value is the independent variable. It is the domain, x value, all of those things. Because whenever x changes, y changes. You'll never see it go backwards, at least not in Algebra 1. Now, if our x variables are the independent variable, then that means our y values are going to be our dependent variable. Whoops, that is not how you spell that word. Never mind, it is how you spell that word. Again, why I'm not an English teacher. So the dependent variables. They are the dependent variables because they don't make any decisions of their own. Okay? Everything the y does is dependent upon the x. If the x changes, the y changes. If the x doesn't change, then the y doesn't change. And that's kind of how it goes. All right, the last thing I want to go over is function notation. I'm going to write over here. Don't know why, but my video is acting up on me. So bear with the different scenery. So function notation. We'll get into this a bit more in the next PowerPoint, such as how to use function notation. But right now, function notation is actually another way to talk about the y value or the dependent variable. Okay? Because y is the dependent variable, it is sometimes referred to as the function of x. So y is often referred to as the function of x. And the way that you write this, the way that you represent this on a graph in an equation is with the symbol f of x. And you actually say that as f of x. Oops. That's how you would say that symbol. F of x literally just means y. Whenever you see an equation that has f of x is equal to something, you can almost substitute y in there. The reason why we do this is because, take this picture right here. Already we have 2 lines on it. What happens if I were to add, let's go with a third, or even better, let's do a fourth. Okay, there are 4 lines on this picture. Now, I'm going a little bit colorblind and I am the one that drew them. And what happens when we have the situation is I can't ask you, what's the slope of the line? Because then you'll follow up with, which line are you talking about? This is where f of x comes in. F of x is just a name for the graph. Because I can name this one f of x, I can name this one g of x, h of x, j of x. All right, whoops, j of x already has a name. and this one could be j of x. It's just a name to refer to the lines in cases where we have a lot of them. That way we can keep things organized and we know which one we're talking about. All right, that's all I have for you today. Make sure you submit your notes to the website, and I'll see you in class.